Okay, so this is section 5.2, which is on kinetics. Alright, what does kinetics refer to? Basically, that tells us how fast a reaction happens. Okay, so when we talk about another term I should say that we can use in this is rate of reaction. Okay. And we're just going, there again, this could be a very detailed subject. In Chem 142, I spend 2 chapters talking about this in a couple weeks in class. But we're just going to give an overview, probably a 5-minute overview of this. And we'll talk about some factors that affect the rate of a reaction. Right. So first of all, we need to kind of backtrack and we need to talk about what's going on in a chemical reaction. Basically, let's say that we have a very, very simple reaction where we have this species and this... I'm not drawing what I want to draw. This species and this species reacting together to make this species. Alright? So, if we think about these, if we have a sample of them, these are moving around randomly. And in order for this reaction to happen, these have to run into each other. They basically have to collide. This is called the collision theory. Not only do they have to collide with each other, though, they have to do it with enough energy to make the reaction happen. And also, this isn't really relevant to a simple molecule, but when we have molecules with more complex shapes, we also have to think about the orientation in which they collide. We will only get a reaction if they're lined up correctly, so to speak. So, talking about that is going to frame how we think about kinetics. Talking about this collision theory lets us predict what happens. Alright, so first thing is temperature. Okay, we increase the temperature, what happens to molecular motion? So, first of all, in general, we get more molecular motion. The molecules are moving faster, which means that they're moving with more energy, and they're moving more. So, if we increase the temperature, collisions are more likely to happen. When collisions happen, they happen with higher energy. So, as we increase the temperature, the rate of reaction also increases. Now, also we can talk about our amount of reactant, or we could say concentration, which is how much reactant we have per unit volume, typically, or mass. So basically, the more molecules we shove in together, the more likely they are to collide with each other. Right? Makes sense, right? So, we increase concentration. In general, we increase the rate of the reaction. Now, there are specific scenarios where increasing the concentration does not increase the rate of the reaction. But when that happens, basically the result is that the rate of reaction stays the same. I'm not aware of any situation, and in fact it would defy anything that I can think to make sense of, where we add more reactant and the rate of reaction decreases. I say that, I shouldn't hold that thought. But for our purposes, though, we're going to consider that if we increase concentration, it's always going to increase the rate. All right, our last thing, though, when we want to increase the rate of the reaction, we can add something called a catalyst. Right? What is a catalyst? Catalyst is a substance that increases the rate of the reaction. But it is not consumed in the reaction. Next time we meet for lab, we're going to actually do couple of experiments where we have to add a small amount of sulfuric acid. Sulfuric acid in those cases is acting as a catalyst. Those are reactions actually that won't happen without a catalyst, but that's sidetracking a little bit also. But anyway, so catalysts increase the rate of the reaction, but they're not consumed in the reaction. By the way they do that is by decreasing the activation energy. So, if we look at a reaction energy diagram, and if this is our normal uncatalyzed reaction, sorry, you can't see that on the screen. If this solid line represents our normal uncatalyzed reaction, we could use this dashed line to represent a catalyzed reaction. Now, notice we start at the same point, we end at the same point. We've just changed the activation energy in here. And that's key in this. Catalysts don't change where we start, they don't change where we end, they just change how we get there. Right. Now, there's another term we can throw out with all of this, which is enzyme. Enzyme is a biological catalyst. Generally, it's a big, complicated protein. Enzymes are perfect catalysts. Enzymes are extremely selective. They're extremely efficient. But yeah, that's so anyway, that covers kinetics for us.